What if I told you that Mars, the red planet, holds secrets so baffling that even the brightest minds on Earth can't fully explain them? For centuries, humanity has gazed at Mars with a mix of awe and curiosity, imagining what lies beneath its dusty, rust-colored surface. Despite decades of exploration, from the Viking missions to the latest rovers, Mars continues to surprise us with phenomena that defy explanation. From strange formations that look eerily artificial to mysterious seasonal changes that hint at hidden processes, Mars is a treasure trove of cosmic mysteries. In this video, we'll uncover 30 of the most puzzling phenomena on Mars, features and events that challenge our understanding of the planet and keep scientists scratching their heads. Could these mysteries hold clues about Mars' ancient past or even its potential for life? Stay with us as we dive into the unknown, exploring everything from the infamous face on Mars to the enigmatic methane spikes in its atmosphere. By the end of this journey, you'll see Mars in a whole new light, a world of endless wonder and unanswered questions. So, are you ready to unravel the secrets of the red planet? Let's begin. Now turning to one of the most iconic and controversial mysteries of Mars, the infamous face on Mars. Discovered by the Viking 1 orbiter in 1976, this peculiar formation in the Cydonia region immediately captured the world's imagination. At first glance, the structure appeared to resemble a human face, complete with what looked like eyes, a nose, and a mouth. This striking image sparked a wave of speculation, with many suggesting it was evidence of an ancient alien civilization that once thrived on Mars. Could this be a monument left behind by intelligent beings, a relic of a long-lost Martian culture? The idea fueled countless conspiracy theories and even inspired books, movies, and documentaries. However, as technology advanced and higher resolution images were captured by later missions like Mars Global Surveyor, the truth became clearer. The face was revealed to be nothing more than a natural rock formation, shaped by the play of light and shadow. Despite this scientific explanation, the face on Mars remains a cultural phenomenon, a symbol of humanity's fascination with the unknown. It continues to intrigue conspiracy theorists and space enthusiasts alike, serving as a reminder of how easily our minds can see patterns and meaning in the unfamiliar. So, while the face on Mars may not be the work of aliens, it still stands as one of the most captivating mysteries of the red planet, a testament to the power of imagination and the enduring allure of Mars. Now turning to another fascinating mystery on Mars, the enigmatic Martian blueberries. These small, spherical formations discovered by the Opportunity rover in 2004 are officially known as hematite concretions. Their nickname, blueberries, comes from their round shape and bluish-gray hue, which stood out against the rusty Martian landscape. But what makes these tiny spheres so intriguing? Scientists believe they formed billions of years ago, likely through a process involving water. One leading theory suggests that groundwater rich in minerals seeped through porous rock, depositing layers of hematite, a mineral often associated with water, around a central core. Over time, these layers built up, creating the spherical shapes we see today. However, the sheer abundance of these blueberries in certain regions, like Meridiani Planum, has left researchers puzzled. Why are there so many of them, and why are they concentrated in specific areas? Some speculate that ancient water activity played a key role, while others propose volcanic processes or even meteorite impacts as possible explanations. The presence of these blueberries has also fueled debates about Mars' past habitability. Could they be evidence of a time when liquid water was more widespread on the planet? While we don't have all the answers yet, these tiny spheres continue to spark curiosity and remind us that even the smallest features on Mars can hold big secrets. As we move forward, the Martian blueberries remain a compelling piece of the puzzle, inviting us to dig deeper into the mysteries of the red planet. Now turning to another intriguing mystery on Mars, the enigmatic recurring Slope Lineae, or RSL. These dark streaks, which appear and disappear on Martian slopes, have puzzled scientists since their discovery. First observed in 2011, these streaks seem to flow down steep hillsides during warmer seasons and fade away when temperatures drop. Initially, researchers believed they were evidence of liquid water flowing on the surface, a tantalizing clue that Mars might still harbor active water sources. The idea was that briny water, rich in salts, could lower the freezing point enough to allow it to flow temporarily, creating these dark streaks. However, further observations have complicated this theory. While some data supports the presence of hydrated salts in these regions, other findings suggest that the streaks could be caused by dry sand flows or other processes entirely. For instance, the lack of detectable water vapor in the atmosphere during these events has raised doubts about the liquid water hypothesis. Some scientists propose that the streaks might be the result of dust avalanches or the movement of fine-grained sand, driven by seasonal changes in temperature and wind patterns. Others speculate that briny water could still be involved, but in much smaller quantities than initially thought, making it difficult to detect. The mystery of the recurring Slope Lineae highlights the challenges of studying Mars from afar and reminds us that even the most promising clues can lead to more questions than answers. As we continue to explore the red planet, these enigmatic streaks remain a focal point of research, offering a glimpse into the dynamic and ever-changing nature of Mars' surface. Now turning to another captivating mystery on Mars, the Methane Mystery. Methane, a gas that can be produced by both biological and geological processes, has been detected in Mars' atmosphere, and its presence fluctuates with the seasons. This discovery has sparked intense interest because methane is often associated with life on Earth. Could it mean that microbial life exists beneath Mars' surface, producing this gas as a byproduct? Or is it the result of geological activity, such as volcanic processes or reactions between water and rock? The seasonal variations add another layer of intrigue, as methane levels rise during warmer months and drop in colder ones, suggesting a dynamic process at work. However, pinpointing the source of this methane has proven to be a significant challenge. The Curiosity rover has detected methane spikes in Gale Crater, but these findings have not always been consistent with observations from orbiters like the European Space Agency's Trace Gas Orbiter. Some scientists argue that the methane could be seeping from underground reservoirs, while others propose that it might be produced by chemical reactions involving minerals and water. The debate continues with no definitive answers yet. The methane mystery underscores the complexity of Mars' environment and the tantalizing possibility that the red planet might still hold secrets about its past or even present habitability. As we gather more data from future missions, this enigmatic gas remains a key piece of the puzzle in our quest to understand Mars. Now turning to the enigmatic origins of Mars' two small moons, Phobos and Deimos. These celestial companions have puzzled scientists for decades, not just because of their unusual shapes and sizes, but also due to the mystery surrounding how they came to orbit the red planet. One leading theory suggests that Phobos and Deimos might be captured asteroids, pulled into Mars' gravitational grip from the nearby asteroid belt. This idea is supported by their irregular shapes and dark, cratered surfaces, which resemble many asteroids we've observed. However, their nearly circular orbits around Mars' equator don't quite fit the typical pattern of captured objects, which usually have more erratic paths. This inconsistency has led to another intriguing theory, that these moons could be remnants of a much larger moon that once orbited Mars. According to this hypothesis, a massive collision in Mars' distant past could have shattered a larger moon into pieces, leaving Phobos and Deimos as the surviving fragments. Adding to the mystery, Phobos is slowly spiraling inward toward Mars and is expected to either crash into the planet or break apart into a ring system in tens of millions of years. Meanwhile, Deimos is gradually drifting away. These opposing fates raise questions about the Moon's long-term stability and their relationship with Mars' gravitational forces. The composition of Phobos and Deimos also adds another layer of intrigue. While they appear similar to asteroids, their densities and surface properties don't perfectly match, leaving scientists to wonder if they might be made of a mix of materials from Mars itself and other sources. The Martian moons remain a fascinating puzzle, and their origins could hold clues not just about Mars' history, but also about the processes that shape planetary systems across the cosmos. As we continue to study these mysterious moons, they remind us that even the smallest objects in our solar system can hold some of the biggest secrets. Now turning to the mysterious dark dunes of Mars, a phenomenon that continues to baffle scientists. These shifting dunes, particularly prominent in regions like Nili Patera, are a striking feature of the Martian landscape. What makes them so intriguing is their movement, which defies expectations given Mars' incredibly thin atmosphere. On Earth, dunes move due to strong winds pushing sand grains across the surface. But on Mars, where the atmosphere is less than 1% as dense as Earth's, the forces required to move such large amounts of sand seem almost impossible. Yet the dunes shift sometimes by several meters in a single Martian year. This raises the question, how do these dunes move so dramatically in such a thin atmosphere? One theory points to the unique properties of Martian sand. Unlike Earth's sand, which is primarily made of silica, Martian sand contains a higher concentration of volcanic basalt, giving it a darker color and potentially different physical properties. This basalt-rich sand might be lighter or more easily lifted by the wind, allowing it to move more freely despite the thin atmosphere. Another theory suggests that Mars' wind patterns, though weaker than Earth's, are more consistent and persistent over time. These steady winds could gradually push the dunes across the surface, creating the movement we observe. Additionally, the low gravity on Mars might play a role, making it easier for sand grains to be lifted and carried by even gentle breezes. The dark dunes of Mars are not just a scientific curiosity, they also provide clues about the planet's climate and geological history. By studying their movement, scientists hope to better understand the forces shaping Mars' surface and how they differ from those on Earth. As we continue to explore these enigmatic dunes, they remind us that even the smallest grains of sand can hold the key to unlocking some of Mars' biggest mysteries. Now turning to the eerie and otherworldly phenomenon known as the Martian Spiders, a feature that seems almost too strange to be real. Found in the south polar region of Mars, these formations are not actual spiders, of course, but their spindly, web-like patterns have earned them this haunting nickname. These spider-like features are created through a process called sublimation, where carbon dioxide ice transforms directly from a solid into a gas without passing through a liquid phase. During the Martian spring, sunlight penetrates the translucent layer of carbon dioxide ice, warming the ground beneath. This causes the ice to sublimate, building up pressure until it bursts through the surface in explosive jets of gas. As the gas escapes, it carries dark dust and debris with it, which then settles back onto the surface, creating the intricate spider-like patterns we observe. The result is a sprawling network of dark, branching channels radiating outward from a central point, resembling the legs of a spider. What makes these formations so fascinating is not just their appearance, but what they reveal about Mars' climate. The seasonal cycle of carbon dioxide ice sublimation and recondensation provides valuable insights into the planet's atmospheric dynamics and temperature fluctuations. Scientists believe that studying these spiders could help us better understand how Mars' polar regions interact with its thin atmosphere and how these processes have evolved over time. Additionally, the presence of these features suggests that Mars' climate is still active and dynamic, with seasonal changes that continue to shape its surface. The Martian spiders are a stark reminder of how alien and mysterious the red planet truly is. offering a glimpse into the complex interplay of ice, gas, and dust that defines its polar landscapes. As we unravel the secrets of these formations, we come one step closer to understanding the broader story of Mars' past, present, and future. Now turning to the enigmatic Medusae-Phossae formation, a geological wonder on Mars that continues to baffle scientists. Stretching across an area comparable to the size of India, this massive deposit of soft rock stands out as one of the most puzzling features on the red planet. Its sheer scale and unusual composition have sparked numerous theories about its origin, with some suggesting it could be the remnants of ancient volcanic ash, while others propose it might be the result of vast ice deposits that have since eroded away. The Medusae-Phossae formation is characterized by its soft, easily eroded material, which has been sculpted by Martian winds into dramatic ridges, grooves, and mesas. These erosion patterns are unlike anything seen elsewhere on Mars, raising questions about the processes that shape them. Some scientists believe that the formation's softness could indicate it was once saturated with water or ice, while others argue that its composition points to a volcanic origin, possibly from explosive eruptions that blanketed the region in ash. What makes this formation particularly intriguing is how it challenges our understanding of Martian geology. Its unique properties suggest that Mars may have experienced geological processes unlike anything we see on Earth, forcing us to rethink our assumptions about the planet's history. The Medusae-Phossae formation also holds clues about Mars' climate evolution, as its erosion patterns provide a record of wind activity over millions of years. By studying this mysterious feature, scientists hope to uncover more about the forces that have shaped Mars' surface and how they differ from those on our own planet. As we continue to explore the Medusae-Phossae formation, we are reminded of how much there is still to learn about the red planet and the secrets it holds. Now turning to the Martian avalanches, a phenomenon that showcases the dynamic and ever-changing nature of the red planet. In 2007, the High-Resolution Imaging Science Experiment camera, or HiRISE, aboard the Mars Reconnaissance Orbiter captured something extraordinary: massive avalanches tumbling down steep cliffs near the planet's north pole. These events were completely unexpected, as Mars' thin atmosphere and cold, dry environment seemed unlikely to support such dramatic surface activity. The avalanches were triggered by the collapse of ice and dust layers on towering cliffs, some of which are as high as 2,000 feet. As these layers broke free, they cascaded down the slopes, creating plumes of dust that stretched for hundreds of feet across the Martian surface. Scientists believe that seasonal changes play a key role in these events. During the Martian spring, sunlight warms the cliffs, causing carbon dioxide ice to sublimate or turn directly from solid to gas. This process destabilizes the overlying layers of ice and dust, making them more prone to collapse. The avalanches provide valuable insights into the planet's geology and climate. They reveal that Mars' surface is far more active than previously thought, with processes like sublimation and seasonal temperature shifts driving significant changes. These events also highlight the importance of studying Mars' polar regions, where unique geological and climatic interactions occur. By analyzing the avalanches, scientists can better understand how materials move and settle on the planet's surface, as well as how its climate has evolved over time. The discovery of Martian avalanches reminds us that even in the harsh, seemingly static environment of Mars, there are forces at work that continue to shape and reshape the landscape, offering new clues about the planet's past and present. Now turning to the Martian dust devils, another fascinating phenomenon that highlights the dynamic nature of the red planet. These towering whirlwinds, some reaching heights of several kilometers, are a common sight on Mars, especially in its vast, dusty plains. Unlike Earth's dust devils, which are relatively small and short-lived, Martian dust devils can grow to immense sizes due to the planet's thin atmosphere and low gravity. They form when the ground heats up during the day, warming the air just above the surface. As this warm air rises, cooler air rushes in to replace it, creating a spinning column of wind that picks up loose dust and debris. The result is a towering vortex that can leave behind intricate, swirling tracks on the Martian surface. These tracks are not just visually striking, they also provide valuable clues about wind patterns and surface conditions. Interestingly, dust devils have played an unexpected role in the success of Mars missions. The rover's spirit and opportunity, for example, benefited from these natural cleaners. As dust devils passed over the rovers, they swept away layers of dust that had accumulated on the solar panels, restoring their power-generating capabilities and extending the mission's lifespan. This accidental discovery has made dust devils a subject of interest not just for their scientific value, but also for their practical implications for future exploration. By studying these whirlwinds, scientists can better understand Mars' weather systems and how they interact with the surface. The Martian dust devils remind us that even in the planet's harsh environment, there are natural processes at work that continue to shape and influence its landscape, offering both challenges and opportunities for exploration. Now turning to the Martian ice caps, a phenomenon that holds some of the most intriguing secrets of the Red Planet. These polar ice caps, located at the north and south poles of Mars, are composed of both water ice and frozen carbon dioxide, also known as dry ice. What makes them particularly fascinating are the mysterious layered deposits that make up their structure. These layers, visible in high-resolution images, are like pages in a book, recording the planet's climate history over millions of years. Scientists believe that the alternating layers of ice and dust were formed by seasonal changes and long-term climate cycles, much like the rings of a tree. However, the exact mechanisms behind these layers and the variations in their composition remain a puzzle. For instance, why do some layers appear thicker than others? What causes the differences in the ratio of water ice to carbon dioxide ice? These questions hint at a complex interplay of atmospheric conditions, temperature fluctuations, and even potential volcanic activity. The ice caps also show signs of sublimation, where the carbon dioxide ice transitions directly from a solid to a gas, creating unique features like spider-like channels and pits. These processes not only shape the ice caps but also influence the planet's atmosphere, making them a key area of study for understanding Mars' climate dynamics. The Martian ice caps are more than just frozen landscapes. They are windows into the planet's past, offering clues about its ancient environment and the forces that have shaped it over time. As we continue to explore these icy regions, we may uncover answers to some of Mars' most enduring mysteries. Now turning to the Martian caves, a phenomenon that opens up a world of possibilities for future exploration and the search for life. These cave entrances, often referred to as skylights, were first spotted in high-resolution images captured by orbiting spacecraft. These dark, circular openings appear to lead into underground caverns, some of which are large enough to fit entire city blocks. What makes these caves so intriguing is their potential to serve as natural shelters for future human missions. The thick rock ceilings could protect astronauts from harmful radiation, extreme temperature swings, and even the frequent dust storms that sweep across the planet. But the excitement doesn't stop there. These caves might also hold clues about the possibility of microbial life on Mars. Underground environments, shielded from the harsh surface conditions, could provide the stable temperatures and protection needed for life to survive, especially if liquid water or ice is present. However, studying these caves from orbit is no easy task. The entrances are often small and difficult to distinguish from shadows or other surface features. Additionally, the interiors remain largely unexplored, leaving scientists to speculate about their depth, structure, and potential contents. future missions equipped with advanced rovers or drones may one day venture into these mysterious caverns, uncovering secrets that could reshape our understanding of Mars and its potential to support life. The Martian caves are not just geological curiosities. They are gateways to a hidden world, offering both challenges and opportunities for the next generation of explorers. Now turning to the possibility of Martian lightning, a phenomenon that sparks both curiosity and debate among scientists. While Earth's lightning is a familiar sight during thunderstorms, the idea of lightning on Mars is far more mysterious. Mars' thin atmosphere, which is about 100 times less dense than Earth's, makes the occurrence of traditional lightning seem unlikely. However, laboratory experiments and observations of Martian dust storms suggest that electrical discharges might still be possible. When dust particles collide during these storms, they can generate static electricity, much like how rubbing a balloon creates a charge. This process, known as triboelectric charging, could lead to small-scale electrical discharges or even larger lightning-like events within the swirling dust clouds. The implications of Martian lightning are significant. If confirmed, it could provide new insights into the planet's atmospheric dynamics and the behavior of its frequent dust storms. For instance, lightning could influence the chemistry of Mars' atmosphere, potentially creating reactive compounds that affect the planet's surface and climate. Additionally, understanding these electrical discharges is crucial for future missions. Lightning, even on a small scale, could pose risks to equipment and astronauts, especially during dust storms when electrical activity might peak. Despite the intriguing possibilities, detecting Martian lightning has proven challenging. Instruments on past missions, such as the Mars Global Surveyor, have searched for signs of lightning but have yet to provide definitive evidence. Future missions equipped with more sensitive detectors might finally settle the debate, revealing whether Mars truly has its own version of lightning. For now, the phenomenon remains one of the red planet's many unsolved mysteries, reminding us just how much we still have to learn about our enigmatic neighbor. As we continue to explore the mysteries of Mars, the next phenomenon takes us to the ghostly remnants of ancient impacts, where buried craters tell a story of the planet's turbulent past. Now turning to the enigmatic Martian ghost craters, these haunting remnants of ancient impacts offer a fascinating glimpse into the red planet's geological past. Ghost craters are essentially the skeletal remains of once prominent impact sites, now buried under layers of sediment and only partially visible. Over millions of years, wind, volcanic activity, and other geological processes have blanketed these craters, leaving behind faint, ghostly outlines that hint at their former glory. These ghostly features are more than just relics of the past. They serve as critical clues to understanding Mars' dynamic history. By studying their shapes, sizes, and the layers of sediment that cover them, scientists can piece together the timeline of events that shape the planet's surface. For instance, the depth and distribution of sediment can reveal periods of intense volcanic activity or ancient climate cycles that once allowed liquid water to flow. In some cases, the sediment itself holds secrets, preserving minerals and compounds that tell stories of Mars' once wetter past. One of the most intriguing aspects of ghost craters is how they challenge our understanding of erosion and deposition on Mars. Unlike Earth, where water and vegetation play major roles in reshaping the landscape, Mars relies on wind and occasional volcanic activity to alter its surface. The ghost crater's persistence, despite being buried for eons, highlights the delicate balance between erosion and preservation on the red planet. These ghostly formations also raise questions about the forces that exposed them. Were they uncovered by powerful dust storms that scoured the surface, or did gradual erosion over millennia reveal their outlines? Each ghost crater tells a unique story, offering a puzzle for scientists to solve as they work to reconstruct Mars' geological history. As we continue to explore these spectral remnants, they remind us that Mars is a world of layers, both literal and metaphorical. Each ghost crater is a window into a different era, a snapshot of the processes that have shaped the planet over billions of years. And as we uncover more of these ancient scars, we come closer to understanding the forces that have made Mars the mysterious world it is today. With the next phase of the journey in sight, we turn our attention to another puzzling feature of Mars' surface, the strange and shifting dark dunes that defy expectations. Now turning to the mysterious Martian mud volcanoes, these peculiar cone-shaped features scattered across the planet's surface have sparked intense debate among scientists. Unlike the towering, fiery volcanoes we're familiar with on Earth, these Martian formations are thought to be the result of mud, not molten rock erupting from beneath the surface. The idea is that ancient water, possibly mixed with sediments, was forced upward under pressure, creating mounds and cones as it spilled out and solidified. The presence of these mud volcanoes, if confirmed, would be a game changer in our understanding of Mars' past. They could serve as evidence of a time when liquid water was abundant beneath the surface, potentially creating environments where microbial life could have thrived. The minerals and compounds found in these formations might also hold clues about the planet's ancient climate and the processes that shaped its geology. However, the theory isn't without controversy. Some scientists argue that these features could be the result of other geological processes, such as lava flows or wind erosion. The challenge lies in distinguishing between mud volcanoes and similar-looking formations created by entirely different mechanisms. High-resolution images and data from rovers and orbiters have provided some insights, but definitive proof remains elusive. What makes these mud volcanoes particularly exciting is their potential as targets for future exploration. If they are indeed remnants of ancient water activity, they could be prime locations to search for signs of past life. Future missions equipped with advanced drilling tools and chemical analyzers could probe these formations, uncovering secrets buried for billions of years. As we continue to study these enigmatic features, they remind us that Mars is a world of surprises, where even the most familiar-looking formations can hold unexpected stories. The Martian mud volcanoes, whether they are what we think they are or something entirely different, represent another piece of the puzzle in our quest to understand the red planet's complex history. With the next phase of the journey in sight, we turn our attention to another fascinating discovery on Mars, the mysterious glass deposits found in its craters, which may hold clues to the planet's ancient past. Now turning to the enigmatic Martian glass deposits, these shimmering formations found within the planet's craters have captured the attention of scientists and space enthusiasts alike. Discovered through data from orbiters and rovers, these glassy materials are believed to have formed during intense meteorite impacts, where the heat and pressure of the collisions melted the Martian soil and rock, creating glass as it rapidly cooled. This process, known as impact melting, is not unique to Mars. Similar glass deposits have been found on Earth and the Moon, but the Martian glass holds its own unique mysteries. What makes these glass deposits particularly intriguing is their potential to preserve ancient microbial life. On Earth, impact glass has been found to contain tiny bubbles of water and even traces of organic material, offering a snapshot of the environment at the time of its formation. If Martian glass contains similar features, it could serve as a time capsule, preserving evidence of life that may have existed billions of years ago. This possibility has made these deposits a high-priority target for future missions, as they could provide critical insights into Mars' habitability and its potential to support life in the past. However, the presence of Martian glass also challenges our understanding of the planet's geological processes. While impact melting is a well-documented phenomenon, the sheer abundance and distribution of these glass deposits on Mars raise questions about the frequency and intensity of meteorite impacts in the planet's history. Were these impacts more common than we thought? Did they play a significant role in shaping Mars' surface and atmosphere? These are questions that scientists are still working to answer, using data from rovers like Curiosity and orbiters like Mars Reconnaissance Orbiter. The study of Martian glass also opens up new avenues for understanding the planet's climate history. The conditions required to form glass, extreme heat and rapid cooling, suggest that Mars experienced periods of intense geological activity. By analyzing the composition and structure of these deposits, researchers hope to piece together a timeline of these events and how they influenced the planet's evolution. As we continue to explore these glassy formations, they remind us that Mars is a world of hidden treasures, where even the most unassuming features can hold profound secrets. Whether they preserve ancient life or simply tell the story of a violent past, the Martian glass deposits are a testament to the planet's complexity and the endless possibilities for discovery. With the next phase of the journey in sight, we turn our attention to another captivating mystery: the ancient river valleys that hint at a time when water flowed freely across the Martian surface. Now turning to the ancient river valleys of Mars, these winding, dried-up channels are some of the most compelling evidence that the red planet once had flowing water. Stretching across the Martian landscape, these valleys bear a striking resemblance to river systems on Earth, complete with branching tributaries and eroded banks. But how could such features exist on a planet that is now so cold and dry? This question lies at the heart of one of Mars' greatest mysteries. Scientists believe these river valleys were carved by liquid water billions of years ago, during a time when Mars may have had a warmer and wetter climate. The presence of minerals like clay and sulfates, which form in the presence of water, further supports this theory. However, the exact mechanisms that allowed liquid water to flow on Mars remain unclear. Some researchers suggest that the planet's atmosphere was once thicker, trapping enough heat to sustain rivers and lakes. Others propose that volcanic activity or asteroid impacts could have temporarily warmed the surface, creating short-lived periods of flowing water. The scale of these river valleys is equally fascinating. Some are hundreds of kilometers long and several kilometers wide, suggesting that water flowed on Mars for extended periods. This raises the possibility that Mars may have once been habitable, with conditions suitable for microbial life. The discovery of ancient river valleys has fueled speculation about whether life ever existed on the planet and whether traces of it could still be found in the sediments left behind. Yet the formation of these valleys also presents a paradox. Mars' current climate is far too cold and its atmosphere too thin to support liquid water on the surface. So, what caused the dramatic shift from a potentially habitable world to the barren desert we see today? Some theories point to the loss of Mars' magnetic field, which allowed solar radiation to strip away its atmosphere over time. Others suggest that changes in the planet's orbit or axial tilt could have triggered a global cooling event. As we study these ancient river valleys, they offer a glimpse into a time when Mars may have been a very different world. They remind us that the planet's history is written in its landscapes, waiting to be deciphered. Whether they tell the story of a once thriving ecosystem or a fleeting moment of warmth, these valleys are a testament to the dynamic and ever-changing nature of Mars. With the next phase of the journey in sight, we turn our attention to another captivating mystery: the mysterious plumes observed in Mars' upper atmosphere, reaching heights of over 200 kilometers. Now turning to the mysterious plumes observed in Mars' upper atmosphere, we encounter one of the most baffling phenomena on the red planet. These towering plumes, reaching heights of over 200 kilometers, have been spotted on multiple occasions, defying our understanding of Martian atmospheric behavior. Imagine a cloud or plume so massive that it stretches far beyond the reach of anything seen on Earth. What could possibly cause such a dramatic feature in a planet with such a thin atmosphere? The first recorded observation of these plumes dates back to March 2012, when amateur astronomers noticed a bright, elongated feature above the Martian surface. Subsequent images from spacecraft like the Hubble Space Telescope confirmed their existence, sparking intense debate among scientists. These plumes appear to form rapidly, sometimes within just 10 hours, and can persist for days before dissipating. Their sheer size and altitude make them unlike anything else observed in the solar system. So, what could be causing these colossal plumes? One leading theory suggests they might be related to auroras, similar to the northern lights on Earth. Mars lacks a global magnetic field, but it does have localized magnetic anomalies that could potentially trigger auroral activity. If these plumes are indeed auroras, they would be far more intense and expansive than anything we've seen before. Another possibility is that they are the result of massive dust storms, which are common on Mars. However, dust storms typically occur closer to the surface and don't explain how material could reach such extreme altitudes. Some researchers have proposed that the plumes could be caused by water ice or carbon dioxide ice particles being lofted high into the atmosphere. On Mars, temperatures in the upper atmosphere can drop low enough for these ices to form, but the mechanisms that would propel them to such heights remain unclear. Others have speculated that volcanic activity, though unlikely given Mars' current state, could be a factor. Yet, no active volcanoes have been detected on the planet, making this explanation highly speculative. Despite years of study, the true nature of these plumes remains a mystery. Their sporadic appearance and the lack of consistent data make them difficult to study in detail. Future missions, equipped with more advanced instruments, may finally shed light on this enigmatic phenomenon. Until then, the Martian plumes stand as a reminder of how much we still have to learn about the red planet. As we prepare to uncover the next mystery, we shift our focus to another intriguing aspect of Mars, the patchy magnetic field that challenges our understanding of planetary magnetism. Now turning to the Martian magnetic field, we encounter a phenomenon that defies our expectations of how planetary magnetism works. Unlike Earth, which boasts a strong, global magnetic field generated by its molten iron core, Mars has a patchy and much weaker magnetic field. This peculiar feature has puzzled scientists for decades, raising questions about the planet's interior and its geological history. The Martian magnetic field is not uniform. Instead, it appears in localized patches primarily concentrated in the southern hemisphere. These patches are remnants of an ancient magnetic field that once enveloped the planet. Evidence suggests that Mars may have had a global magnetic field billions of years ago, similar to Earth's, but it mysteriously faded away. The reasons behind this disappearance remain one of the greatest enigmas in planetary science. One leading theory is that Mars' core cooled and solidified over time, shutting down the dynamo effect that generates magnetic fields. Without a molten core to create electric currents, the planet lost its global magnetic shield. This would have had profound consequences for Mars' atmosphere and surface, leaving it vulnerable to the harsh solar wind and radiation that stripped away much of its air and water. The patchy magnetic fields we see today are likely fossilized remnants of this ancient dynamo, preserved in certain regions of the planet's crust. These magnetic anomalies provide a window into Mars' past, offering clues about its early geological activity and the processes that shaped its surface. For instance, the presence of these patches suggests that Mars once had a more active interior, with volcanic activity and tectonic movements that allowed magnetic minerals to align and solidify in specific patterns. Studying these magnetic anomalies also helps scientists understand how Mars transitioned from a potentially habitable world to the barren planet we see today. The loss of its magnetic field would have exposed the planet to intense solar radiation, gradually eroding its atmosphere and making it inhospitable for life as we know it. This raises intriguing questions about whether Mars could have supported life in its distant past and what factors led to its dramatic transformation. Despite decades of research, many mysteries about the Martian magnetic field remain. Why did the dynamo shut down? Why are the magnetic patches so unevenly distributed? and what does this tell us about the planet's interior structure? Future missions equipped with advanced magnetometers and seismic instruments may provide answers to these questions, helping us piece together the story of Mars' magnetic past. As we continue to unravel the secrets of the red planet, we now turn our attention to another fascinating mystery, the discovery of liquid water beneath Mars' south polar ice cap, a finding that has sparked both excitement and controversy in the scientific community. Now turning to the Martian subsurface lakes, we dive into one of the most hotly debated discoveries in recent planetary science. In 2018, the Mars Express orbiter detected bright radar reflections beneath the planet's south polar ice cap, suggesting the presence of liquid water. This finding sent shockwaves through the scientific community, as liquid water is a key ingredient for life as we know it. The radar data revealed a large, highly reflective area about 1.5 kilometers below the ice, spanning approximately 20 kilometers across. Scientists interpreted this as evidence of a subsurface lake, kept liquid by the high pressure from the overlying ice and the presence of salts, which lower the freezing point of water. If confirmed, this would be the first stable body of liquid water ever found on Mars, raising tantalizing possibilities about the planet's potential to harbor life. However, not everyone is convinced. Some researchers argue that the radar signals could be caused by other materials, such as clay minerals or briny slush, rather than pure liquid water. These substances can also produce strong radar reflections, complicating the interpretation of the data. Additionally, the extreme cold and high salinity required to keep water liquid under these conditions would make it a harsh environment for any potential microbial life. The debate intensified when follow-up studies using different radar instruments failed to detect similar reflections in other parts of the polar region. This inconsistency has led some scientists to question whether the initial discovery was a one-off anomaly or part of a larger network of subsurface lakes. Others suggest that the radar signals might be influenced by the unique properties of the Martian ice, such as its temperature or composition, which could create misleading reflections. Despite the controversy, the possibility of subsurface lakes on Mars remains a compelling area of research. If they exist, these lakes could provide critical insights into the planet's hydrological history and its potential to support life, either in the past or even today. Future missions, equipped with more advanced radar systems and possibly even drilling capabilities, may finally resolve this mystery. As we continue to explore the red planet, the search for liquid water remains a central theme, driving our quest to understand Mars' past, present, and potential for life. With this in mind, we now turn to another dynamic phenomenon, the planet-wide dust storms that have both fascinated and challenged scientists and rovers alike. Now turning to the Martian dust storms, we explore one of the most dramatic and unpredictable phenomena on the red planet. These planet-wide storms can engulf Mars for months, transforming its surface into a hazy, orange-brown world. Unlike anything we experience on Earth, these storms are fueled by Mars' thin atmosphere and unique weather patterns, making them a fascinating yet challenging subject for scientists. Dust storms on Mars typically begin as small, localized events, often triggered by temperature differences between the surface and the atmosphere. As winds pick up loose dust particles, they create a feedback loop. The dust absorbs sunlight, warming the air and generating stronger winds, which in turn lift even more dust. This cycle can escalate rapidly, turning a small storm into a global event that blankets the entire planet. Some of these storms can last for weeks or even months, obscuring the surface from view and dramatically altering the planet's climate. One of the most notable examples occurred in 2018, when a massive dust storm engulfed Mars, leading to the end of the Opportunity rover's mission. The storm blocked sunlight from reaching the rover's solar panels, cutting off its power supply and leaving it unable to communicate with Earth. This event highlighted the challenges of operating on a planet where the environment can change so drastically and unpredictably. But dust storms aren't just a hazard for rovers, they also play a significant role in shaping Mars' climate. By redistributing dust across the planet, these storms influence temperature patterns and even contribute to the formation of features like the polar ice caps. The dust can also affect the planet's albedo or reflectivity, which in turn impacts how much sunlight is absorbed or reflected back into space. Scientists are still working to understand why some dust storms grow to global proportions while others remain localized. Factors such as the planet's elliptical orbit, seasonal changes, and the distribution of dust sources all likely play a role. Future missions, including those with advanced weather monitoring instruments, may help unravel these mysteries and improve our ability to predict these colossal events. As we continue to study Mars, the planet's dust storms remind us of its dynamic and ever-changing nature. These storms not only challenge our exploration efforts, but also offer valuable insights into the complex interplay between the planet's atmosphere, surface, and climate. With this in mind, we now turn to another intriguing feature of Mars, the polygonal terrain found in its polar regions, where the planet's icy secrets await discovery. Now turning to the Martian polygonal terrain, we uncover another fascinating feature of the red planet's polar regions. These intricate patterns, resembling cracked mud or honeycombs, are formed by the repeated freezing and thawing of ice beneath the surface. As temperatures drop, the ice contracts, creating cracks that fill with loose material. When the ice expands again during warmer periods, the cracks are pushed apart, forming the distinctive polygonal shapes we see today. These patterns are strikingly similar to those found in Earth's Arctic and Antarctic regions, where permafrost undergoes similar cycles of contraction and expansion. This resemblance provides scientists with a valuable analog for understanding Mars' climate history. By studying these polygons, researchers can infer details about the planet's past temperatures, the presence of water ice, and even the frequency of climate cycles over millions of years. The polygonal terrain also offers clues about the distribution of ice on Mars. Some polygons are shallow, indicating ice near the surface, while others are deeper, suggesting more extensive ice deposits below. This variability helps scientists map the planet's subsurface ice and assess its potential as a resource for future human missions. Additionally, the size and shape of the polygons can reveal information about the thickness of the ice and the intensity of the temperature changes that form them. One of the most intriguing aspects of these features is their potential connection to seasonal changes on Mars. Observations from orbiters like the Mars Reconnaissance Orbiter have shown that some polygons appear to grow or shrink slightly over time, possibly in response to seasonal temperature fluctuations. This dynamic behavior suggests that the processes shaping the polygonal terrain are still active today, offering a glimpse into the ongoing evolution of Mars' polar regions. As we continue to explore these icy landscapes, the polygonal terrain serves as a reminder of the complex interplay between Mars' climate, geology, and potential for harboring life. These features not only deepen our understanding of the planet's past, but also highlight the challenges and opportunities that await future explorers. With this in mind, we now turn to another enigmatic aspect of Mars, the layered sedimentary rocks found in places like Gale Crater, where the planet's ancient environments are preserved in stone. Now turning to the layered sedimentary rocks of Mars, we find ourselves staring into the planet's ancient past. These striking formations, particularly prominent in Gale Crater, are like pages in a geological history book, each layer preserving clues about the environments that shaped them. The rocks, stacked one atop another, reveal a story of wind, water, and time, offering scientists a rare glimpse into the conditions that once prevailed on the red planet. The layers are thought to have formed through a combination of processes, including the deposition of sediments by ancient rivers, lakes, and wind. Over millions of years, these sediments were compacted and cemented into rock, creating the intricate patterns we see today. What makes these formations so fascinating is their ability to record changes in Mars' environment. For example, some layers contain minerals like clay, which form in the presence of water, while others are rich in sulfates, suggesting drier, more acidic conditions. This alternating sequence hints at a dynamic climate that shifted between wet and dry periods, raising questions about the planet's ability to support life. One of the most compelling mysteries surrounding these layered rocks is their precise origins. While scientists have identified several possible mechanisms, such as volcanic ash deposits or wind-blown sediments, the exact processes remain unclear. The Curiosity rover, which has been exploring Gale Crater since 2012, has provided invaluable data, but many questions persist. For instance, why do some layers appear so uniform, while others show dramatic variations in thickness and composition? And what caused the abrupt transitions between different types of sedimentary deposits? These questions are not just academic, they have profound implications for our understanding of Mars' habitability. If the layers were formed by water, as some evidence suggests, they could indicate periods when the planet was more Earth-like, with lakes and rivers that might have supported microbial life. Alternatively, if wind played a dominant role, it would paint a picture of a drier, more hostile world. Either way, the layered rocks of Gale Crater are a treasure trove of information, offering tantalizing hints about Mars' ancient environments and the forces that shaped them. As we continue to study these formations, they remind us of the complexity and richness of Mars' geological history. Each layer is a piece of the puzzle, helping us reconstruct the planet's past and assess its potential for harboring life. With this in mind, we now shift our focus to another intriguing phenomenon, the sulfur-rich deposits found in regions like Meridiani Planum, where Mars' chemical history is written in stone. Now turning to the sulfur-rich deposits of Mars, we uncover another layer of the planet's enigmatic history. These deposits, prominently found in regions like Meridiani Planum, are a striking reminder of Mars' complex chemical past. Sulfur, a key element in many geological processes, is abundant in these areas, and its presence has sparked intense scientific interest. Why? Because sulfur often interacts with water, and its discovery on Mars could be a crucial clue in understanding the planet's ancient environment. The sulfur-rich deposits are thought to have formed through a combination of volcanic activity and interactions with water. On Earth, sulfur compounds are often associated with hydrothermal vents, hot springs, and other water-rich environments. Similarly, on Mars, these deposits suggest that water may have played a significant role in their formation. For instance, the mineral jarosite, which contains sulfur and forms in acidic, water-rich conditions, has been detected in Meridiani Planum. This discovery points to the possibility that Mars once had lakes or groundwater systems with the right chemistry to create such minerals. However, the story isn't as straightforward as it seems. While the presence of sulfur supports the idea of past water activity, it also raises questions about the nature of that water. Was it abundant and long-lasting, or sporadic and short-lived? The acidic conditions implied by minerals like jarosite suggest that any water present may have been harsh and potentially inhospitable to life as we know it. This adds another layer of complexity to the ongoing debate about Mars' habitability. Another challenge lies in explaining how these sulfur deposits formed in such large quantities. Some scientists propose that volcanic eruptions released sulfur dioxide into the atmosphere, which then settled on the surface and reacted with water. Others suggest that groundwater percolating through the Martian crust dissolved sulfur from rocks, depositing it in concentrated layers over time. Yet, despite these theories, the exact processes remain unclear, leaving room for further exploration and discovery. The significance of these sulfur deposits extends beyond their formation. They serve as a chemical record of Mars' past, offering insights into the planet's climate, geology, and potential for life. By studying them, scientists hope to piece together a more complete picture of how Mars evolved from a potentially habitable world to the arid, barren planet we see today. As we continue to unravel these mysteries, the sulfur-rich deposits of Meridiani Planum stand as a testament to the enduring allure of Mars and the secrets it still holds. With this in mind, we now turn our attention to another fascinating phenomenon: the strange tracks left by dust devils and rovers on Mars' surface, where the planet's wind patterns and surface properties come to life. Now turning to the Martian dust tracks, we uncover yet another fascinating feature of the red planet's dynamic surface. These tracks, left behind by both natural forces like dust devils and human-made rovers, offer a unique window into Mars' ever-changing environment. Dust devils, towering whirlwinds of dust and sand, are a common sight on Mars, and their tracks crisscross the landscape in intricate patterns. Similarly, the rovers we've sent to explore Mars, like Curiosity and Perseverance, leave their own distinctive marks as they traverse the terrain. But these tracks are more than just footprints. They tell a story about the planet's wind patterns, surface composition, and even its hidden secrets. Dust devil tracks, for instance, reveal the direction and strength of Martian winds. By studying their paths, scientists can map out wind patterns across the planet, helping us understand how the thin Martian atmosphere moves and shapes the surface. These tracks also provide clues about the texture and properties of the soil. For example, the way dust devils carve into the surface can indicate whether the soil is loose and sandy or more compacted. This information is crucial for planning future missions, as it helps engineers design equipment that can navigate the terrain effectively. Rover tracks, on the other hand, offer a different kind of insight. As rovers like Curiosity and Perseverance roll across the surface, their wheels disturb the top layer of soil, sometimes revealing what lies beneath. In some cases, these tracks have uncovered buried rocks, minerals, or even layers of ancient sediment that were previously hidden from view. This accidental excavation has led to unexpected discoveries, such as the detection of clay minerals in Gale Crater, which suggest the presence of past water activity. In this way, rover tracks act as unintentional tools for exploration, peeling back the surface to expose Mars' geological history. But the story of these tracks doesn't end there. Over time, wind and dust storms can erase or alter them, creating a dynamic interplay between the planet's surface and its atmosphere. This constant reshaping of the landscape highlights the active nature of Mars, even in its seemingly barren state. By studying how these tracks change over time, scientists can gain a deeper understanding of the processes that continue to shape the planet today. The Martian dust tracks, whether left by nature or human ingenuity, serve as a reminder of the interconnectedness of Mars' systems. They provide valuable insights into the planet's wind patterns, surface properties, and hidden features, all while offering a glimpse into the challenges and opportunities of exploring this enigmatic world. As we continue to study these tracks, we move closer to unraveling the mysteries of Mars, one footprint at a time. With this in mind, we now turn our attention to another intriguing phenomenon: the frost that forms on Mars' surface during colder seasons, where the planet's climate reveals yet another layer of its complexity. Now turning to the Martian frost, we uncover another layer of the red planet's seasonal behavior. During colder seasons, particularly in the polar regions and some mid-latitude areas, a thin layer of frost forms on the surface of Mars. This frost, however, is not like the frost we see on Earth. While Earth's frost is primarily made of water ice, Martian frost is a mix of water ice and carbon dioxide ice, also known as dry ice. This unique composition is a direct result of Mars' thin atmosphere and its predominantly carbon dioxide-rich environment. The formation of Martian frost is a fascinating process. As temperatures drop during the Martian night or winter, carbon dioxide in the atmosphere condenses directly into ice on the surface, creating a delicate layer of frost. In some regions, water vapor in the atmosphere also freezes, adding to the frost's complexity. This dual composition makes Martian frost a key indicator of the planet's atmospheric conditions and seasonal changes. But what's even more intriguing is the uneven distribution of this frost. While it blankets the polar regions and some mid-latitude areas, it is conspicuously absent in others, even under similar temperature conditions. Scientists have been puzzled by this uneven distribution for years. One theory suggests that the presence of frost depends on the availability of water vapor in the atmosphere, which varies across the planet. Regions with higher humidity are more likely to see frost formation, while drier areas remain frost-free. Another factor could be the surface properties of Mars itself. Certain terrains, such as rocky or shaded areas, may retain heat differently, preventing frost from forming even when temperatures drop. Additionally, the planet's thin atmosphere and low pressure play a role as they affect how quickly heat is lost from the surface, influencing where and when frost can appear. The study of Martian frost is not just an academic exercise, it has practical implications for understanding the planet's climate and potential habitability. Frost formation and sublimation are part of the seasonal cycle that drives weather patterns on Mars, including the infamous dust storms. By mapping where frost forms and how it behaves, scientists can gain insights into the planet's water cycle, atmospheric dynamics, and even the potential for liquid water to exist in certain conditions. As we continue to explore Mars, the mystery of its frost remains a compelling puzzle. Why does it appear in some regions but not others? What does its composition tell us about the planet's past and present climate? These questions remind us that even the smallest features on Mars can hold the key to understanding its larger story. With this in mind, we now turn our attention to another intriguing phenomenon: the impact of global dust storms on Mars rovers, where the planet's extreme weather reveals both challenges and opportunities for exploration. Now turning to the impact of Martian dust storms on rovers, we uncover a dramatic chapter in the story of Mars exploration. Global dust storms on Mars are not just a spectacle, they are a formidable challenge for the robotic explorers we send to the Red Planet. These storms, which can grow to engulf the entire planet, have tested the limits of our technology and reshaped our understanding of Mars' harsh environment. One of the most poignant examples of this is the fate of the Opportunity rover. Launched in 2003, Opportunity was a marvel of engineering, designed to explore the Martian surface and search for signs of past water activity. For over 14 years, it exceeded all expectations, traveling more than 28 miles and sending back invaluable data. However, in 2018, Opportunity faced its greatest challenge, a planet-wide dust storm that blocked sunlight for months. Without sunlight to power its solar panels, the rover fell silent, and despite repeated attempts to re-establish contact, it was declared lost in 2019. The loss of Opportunity was a stark reminder of the unpredictable and extreme nature of Martian weather. Dust storms on Mars are unlike anything on Earth. They can last for weeks or even months, with winds reaching speeds of up to 60 miles per hour. While these winds are not as powerful as those on Earth due to Mars' thin atmosphere, they can lift vast amounts of fine dust into the air, creating a thick haze that obscures the sun and blankets the surface. For solar-powered rovers like Opportunity, this poses a critical threat, as the lack of sunlight can drain their batteries and leave them unable to function. But the challenges don't end there. Dust storms also affect the rover's instruments and mechanical systems. Fine dust can settle on solar panels, reducing their efficiency, or infiltrate moving parts, causing wear and tear. Even the rover's cameras and sensors can be affected, as the dust in the air scatters light and distorts images. These factors make operating during a dust storm a delicate balancing act, requiring careful planning and resource management. Despite these challenges, the study of Martian dust storms has yielded valuable insights. For instance, we've learned that these storms play a key role in the planet's climate, redistributing heat and dust across the surface. They also provide clues about the planet's atmospheric dynamics, such as how dust particles are lifted and transported. Moreover, the experience of operating rovers during dust storms has informed the design of future missions, leading to innovations like more robust power systems and dust-resistant components. As we look to the future, the lessons learned from Opportunity and other rovers will guide our efforts to explore Mars more effectively. The next generation of rovers, like Perseverance, are equipped with advanced technologies to withstand the planet's harsh conditions. Yet, the mystery of Martian dust storms remains a reminder of the red planet's unpredictable nature. What drives these storms to grow so large? How do they shape the planet's surface and atmosphere over time? These questions continue to drive our exploration as we seek to unravel the secrets of Mars' ever-changing landscape. With this in mind, we now turn to another fascinating phenomenon: the discovery of vast amounts of subsurface ice on Mars, where the planet's hidden reserves of water hold the promise of new discoveries. Now turning to the hidden reserves of water on Mars, we delve into the discovery of vast amounts of subsurface ice, a phenomenon that could hold the key to future exploration and even human habitation on the red planet. Beneath the barren, dusty surface of Mars lies a treasure trove of ice, buried in layers that stretch deep into the planet's crust. This ice, discovered through radar data from orbiting spacecraft and ground-penetrating instruments on rovers, has sparked excitement and curiosity among scientists and space enthusiasts alike. The presence of subsurface ice is significant for several reasons. First and foremost, it represents a potential resource for future human missions. Water is essential for survival, and extracting ice from beneath the surface could provide astronauts with drinking water, oxygen for breathing, and even hydrogen for fuel. This would reduce the need to transport these resources from Earth, making long-term missions more feasible. Additionally, the ice could offer clues about Mars' past climate and its potential to support life. If liquid water once flowed on Mars, as evidence suggests, this ice could be a remnant of that ancient, wetter era. But how did this ice form, and how has it persisted in Mars' dry, frigid environment? These questions remain a mystery. One theory suggests that the ice accumulated over millions of years as water vapor in the atmosphere condensed and froze in the cold subsurface layers. Another possibility is that the ice is the result of ancient glaciers or snow deposits that were buried by dust and sediment over time. The planet's axial tilt, which has varied dramatically over its history, may have also played a role, causing ice to migrate and accumulate in certain regions. The persistence of this ice is equally puzzling. Mars' thin atmosphere and low temperatures create conditions where ice can remain stable underground, shielded from the sun's direct rays. However, the planet's surface is also subject to sublimation, where ice turns directly into vapor without melting. This raises questions about how the subsurface ice has managed to survive for so long. Some scientists believe that a layer of dust or rock acts as an insulating blanket, protecting the ice from sublimation and preserving it over geological timescales. The discovery of subsurface ice has already influenced the planning of future missions. For example, NASA's upcoming Mars Ice Mapper mission aims to map the distribution and depth of this ice in greater detail, identifying potential landing sites for human explorers. Meanwhile, rovers like Perseverance are equipped with instruments to study the composition and structure of the ice, shedding light on its origins and history. As we continue to explore Mars, the mystery of its subsurface ice reminds us of the planet's hidden complexities. What other secrets lie beneath the surface? Could this ice hold evidence of past or even present microbial life? And how can we harness this resource to pave the way for human exploration? These questions drive our quest to understand Mars as we uncover the clues that lie frozen beneath its dusty exterior. With this in mind, we now turn to another intriguing phenomenon, the possibility of lightning during Martian dust storms, where the planet's atmosphere reveals yet another layer of its enigmatic nature. Now turning to the electrifying mystery of Martian lightning storms, we explore a phenomenon that could reshape our understanding of the red planet's atmosphere. While Earth's thunderstorms are a familiar sight, the idea of lightning on Mars has long been a topic of debate among scientists. Could the planet's massive dust storms, which can engulf the entire globe, generate electrical discharges similar to lightning? The evidence is intriguing but far from conclusive. On Earth, lightning is typically produced by the collision of ice particles within storm clouds, creating an electrical charge. However, Mars' atmosphere is vastly different, thin, dry, and lacking the water vapor necessary for traditional thunderstorms. Yet, laboratory experiments have shown that under certain conditions, dust particles rubbing against each other in Martian dust storms could generate static electricity, potentially leading to lightning. This phenomenon, known as triboelectric charging, has been observed in volcanic ash clouds on Earth, raising the possibility that something similar could occur on Mars. The evidence for Martian lightning is indirect but compelling. Some spacecraft observations have detected unusual electromagnetic signals during dust storms, which some scientists interpret as potential lightning activity. However, these signals could also be caused by other atmospheric processes, leaving the question unresolved. Adding to the mystery, no spacecraft or rover has yet captured a direct image or recording of Martian lightning, making it difficult to confirm its existence. The implications of Martian lightning are significant. If it does occur, it could provide valuable insights into the planet's atmospheric dynamics and the behavior of dust storms. Lightning could also pose a hazard for future missions, potentially damaging equipment or interfering with communication systems. Understanding this phenomenon is crucial for ensuring the safety of astronauts and the success of long-term exploration efforts. As we continue to study Mars, the question of lightning remains a tantalizing puzzle. Could these electrical discharges be more common than we think? And what might they reveal about the planet's past and present climate? With each new mission, we edge closer to uncovering the truth, as Mars continues to surprise us with its hidden complexities. With this in mind, we now turn to the final mystery in our exploration: the theory that Mars once had a vast ocean covering its northern hemisphere, a discovery that could rewrite the history of the red planet. Now turning to the final mystery in our exploration of Mars, we delve into the theory that the red planet once hosted a vast ocean covering its northern hemisphere. This idea, if proven true, could fundamentally reshape our understanding of Mars' history and its potential for harboring life. The evidence for this ancient ocean is both compelling and controversial, sparking ongoing debates among scientists. One of the most striking pieces of evidence comes from the planet's topography. Mars' northern lowlands are remarkably flat and lie at a lower elevation than the southern highlands, resembling the kind of basin that could have held a massive body of water. Some researchers argue that these lowlands were once the floor of an ocean, with features resembling ancient shorelines etched into the landscape. These so-called shorelines appear to follow contours that would be consistent with the presence of water, though their exact origin remains a topic of debate. Mineral deposits also provide tantalizing clues. Certain regions of Mars, particularly in the northern plains, contain minerals like clays and sulfates that typically form in the presence of water. The Curiosity rover, for example, has detected sedimentary rocks in Gale crater that suggest the area was once a lakebed. These findings hint at a time when liquid water was abundant on Mars, potentially pooling into a vast ocean. However, not all scientists are convinced. Some argue that the shorelines could be the result of other geological processes, such as volcanic activity or tectonic shifts, rather than ancient oceans. Additionally, the planet's thin atmosphere and cold temperatures make it difficult to explain how such a large body of water could have existed for an extended period. If Mars did have an ocean, where did all that water go? Some theories suggest it evaporated into space, while others propose it may have retreated underground, forming subsurface ice or briny reservoirs. The fate of this hypothetical ocean is just as mysterious as its existence. If Mars once had a stable climate capable of supporting liquid water, what caused it to change so dramatically? Was it a gradual loss of atmosphere, a catastrophic event, or a combination of factors? These questions remain unanswered, but they are central to understanding whether Mars could have ever been habitable. As we conclude our journey through the unexplained phenomena of Mars, the theory of an ancient ocean stands as one of the most captivating mysteries. It challenges us to rethink the planet's past and consider the possibility that Mars was once a world teeming with water, and perhaps even life. With each new mission and discovery, we inch closer to unraveling this enigma, reminding us that the red planet still holds countless secrets waiting to be uncovered. Now turning to the conclusion of our exploration, we've journeyed through 30 of the most baffling phenomena on Mars, each one a testament to the planet's enigmatic nature. From the infamous face on Mars to the mysterious methane fluctuations, the recurring Slope Lineae, and the haunting possibility of an ancient ocean, these mysteries remind us just how much we still have to learn about the red planet. Each discovery raises new questions, challenging our understanding of Mars' past, present, and potential for life. These unexplained phenomena highlight the complexity of Mars, a world that continues to surprise and intrigue us. They also underscore the limits of our current knowledge, showing that even with decades of exploration, Mars remains a treasure trove of secrets waiting to be uncovered. As we look to the future, missions like the Perseverance rover and the upcoming Mars Sample Return Project promise to bring us closer to answers, but they will undoubtedly reveal even more mysteries to ponder. So, what do you think about these Martian enigmas? Do you believe the face on Mars is a natural formation, or could it hint at something more? Are the recurring Slope Lineae evidence of liquid water, or is there another explanation? Share your thoughts in the comments below. We'd love to hear your theories and ideas. And if you're as fascinated by the mysteries of space as we are, don't forget to subscribe and hit the notification bell so you never miss an update on the latest discoveries. The universe is full of wonders, and Mars is just the beginning. Stay curious, keep exploring, and who knows, maybe one day you'll help solve one of these cosmic puzzles.